What's up guys, welcome to the channel. Today on this video we'll be doing limits. So before we start with limits, probably you're asking yourself what is a limit. So I have a definition here, so I'm gonna read it to you guys. So the definition of a limit is the value that a function approaches as the input approaches some value. So I'm gonna show you what do they mean by that as we solve the limits. So we have three ways that we can evaluate limits. So the first one, or the first step, is direct substitution. So basically here on this step, what do we do is, let's say we are given the problem like this one. Let's say limit and then they say x is approaching, let's say x is approaching 1, and your limits that you have here, let's say the function is x squared plus 2x. So remember that definition. They say is the value in a fraction, which is in this case that value is x, which is approaching input. That input in this case is 1. Alright, so basically that's what they mean. So when you look at this, you can say limit x squared plus 2x, and then we know that x is approaching 1. So the first step is to substitute. Direct substitution, meaning you're going to substitute 1 where there is x, since x is approaching 0. So basically this is how you're going to do. You rewrite this equation and say 1 squared, because there is x is approaching 1 there, plus 2, 1 multiplied by 1, since x is approaching 1 there. So when we continue, this is gonna give us 3. So that is our answer. So when you do direct substitution and you get an answer, you stop here. That is the final answer, unless you need to continue and maybe represent it on a graph or something. Alright, so from here, what else can we do? Now let's say we are given a problem. Whereby we have maybe, let's say we have limit, let's say x is approaching, let's say x is approaching, let's make it x is approaching 2. Yes, and then our function here is 2x squared minus 4 divided by x minus 2. Alright, so if we do direct substitution, let's continue here. If we do direct substitution, we're gonna have remember x is approaching 2, we're gonna have 2 squared, substitute 2 there where there is x, divided by 2 minus 2. Now as you can see, this gives us 0 over 0. We cannot accept this answer, or even if it gives us 0, or if it gives us infinity. If our direct substitution gave us 0 or infinity, we need to go to step number 2. Now what is step number 2? Now step number 2, I'm gonna write it here. Step number 2 is simplification. Let me just write simplification. Alright, basically what it means, when you do direct substitution, just like this problem here, and then the answer is 0 or infinity, you have to go to simplification. You have to do simplification. Now let's do the very same problem, and then we do step number 2. So we have x squared minus 4 divided by x minus 2, and then we know that x is approaching 0. So is approaching 2, guys, not 0. X is approaching 2, just like the one we did here. Now we know that with direct substitution this is gonna give us 0, so you have to simplify this. So if you continue simplifying this one, we know that the numerator there is difference of 2 squares, so we simplify it that way, and then we have the following, and then we divide by x minus 2. Alright, let's go. X is approaching 2. So when we continue like that, now we can substitute. Before though we substitute, we have to simplify. You guys see, we know that x minus 2 divided by x minus 2 is gonna give us 1, so we are left with x plus 2. Okay, and we know that this limit x approaches 2, so we can start doing the direct substitution. After simplifying, that's where we do direct substitution. So we can say where there's x, we put 2 plus 2. So our answer, when you look at this, our answer is gonna be 4. So basically that's what we do when we are doing limits. So sometimes you do the direct substitution and it gives you 0. If it gives you 0, then you move to the next step, which is step number 2. So step number 2, what you do here is you simplify. After simplifying, then you do direct substitution. But what happens if you can't simplify? Let's say you are given a problem. Let me just look for a problem. Let's say you are given a problem whereby when you do direct substitution you get 0 and you can't simplify. How can you solve this one? Let's look at this one here, number 3, which is the other step. Let's say you're given, let's just go back. Let's say you're given this problem here. Let's say you're given this problem here, limit, and then x is approaching infinity, and then you have the following. Maybe you have 5x, and then plus 2. Let's make it plus 2, and then let's divide it by 3 plus 4x squared. Alright, so let's say you have this. So x is approaching infinity. As you can see, you can't simplify this, guys. This is as good as it can be. You can't take out the common factor, you can't do anything. And as well, x here is approaching infinity. If you substitute, you're gonna have 5 multiplied by infinity squared plus 7 plus 2, and then you're gonna have 3, and then plus 3 plus 4, and then infinity squared, and meaning our answer here is gonna be infinity over infinity. It's gonna be infinity divided by infinity. So we can't do this, guys. We can't do this. So step number 1, direct substitution, give us infinity. Step number 2, we can simplify. So what do we do? So the third step, when it's like this, let's continue with our same problem here, limit, and then we say x approaches infinity, and then we say our function 5x squared plus 2 divided by 3 plus 4x squared. So when it's like this, guys, what you should do is you divide with the x that has the highest value. That is the third step. So you divide by the x with the highest power, in fact, not value. So what is the highest power here? Which x has the highest power? They both have the highest power of 2. So you divide by it. So how are you gonna do it? So you write limit, okay, and then x approaches infinity. So basically you're gonna divide each term. So let me do it this way. You can say 5 and then x squared divided by x squared. Remember, you divide by the limit with the highest. We divide the x with the highest power. So plus, this is the numerator, by the way, and then we say 2, and we also divide it by x squared. And then because this is divide, so this is going to be divided. Okay, and then we have 3 divided by x squared, and then we have plus 4, and then we have x squared divided by x squared. So as you can see, each term there is divided by x squared because that x is the one with the highest power. So if we continue like this, we're gonna have the following. Let me just write this. We're gonna have the following. We're gonna have 5 divided by 1 because we know that x squared divided by x squared, you're gonna be left with 1. This one, there's nothing we can do. We still have x squared. Alright, so we're gonna have the same thing this side. We're gonna do the same thing this side, whereby we're gonna have 3 divided by x squared plus, but this one is gonna be giving us 1, so you're gonna be left with 4 over 1, and that is that. Now you start doing your direct substitution here. So when you do it, this is gonna be 5 over 1, and that will be plus 2, and then you put limit squared where there is x. Remember, x is approaching infinity. Then you do that, and then you divide, and then you continue. This is gonna be 3, and then this is gonna be infinity squared divided by infinity squared plus 4 divided by 1. Alright, let's create more space. This is a bit longer than I anticipated. Alright, so when you continue, remember, when you divide by infinity, your answer is gonna be 0. So let's start with this one here. We have 5 over 1 plus 0. Remember, you divided by infinity, so it's gonna be 0. And then divide by, and then this is gonna be 3, and then, oh, sorry guys, not 3. This is gonna be 0, not 3, not 3. It's gonna be 0 because it's divided by infinity plus 4 over 1. Now if you continue, this is gonna give us 5. If we change this and make it multiplication, it's gonna be 1 over 4. So our final answer is gonna be 5 over 4. So that's how you do it, guys, when you have a problem like this one. So let's go back and recap, guys. So first, when you are given a function or a limit, you do a direct substitution, and then when you do a direct substitution and you're able to find an answer just like this one here, which is 3, then that is correct. If you do direct substitution for this one, as you can see, this one here, the direct substitution, whether it gives you 0 or unlimited infinity, it means now you have to do the second step. Now the second step here is simplification. You have to simplify. As you can see, this problem here, we are simplifying it here on this one here. As we simplify, we get to this point, then we start to do direct substitution, and our answer is gonna give us 4. Now we sometimes have problems whereby you cannot do direct substitution, you cannot simplify. What do you do? For example, we have this problem here, so here on this problem, you are given this function and then the limit, and then we know that x is approaching infinity. So what do you do here? you cannot do direct substitution, you can't simplify. And when you do direct substitution, you're gonna get infinity, which is not acceptable again. So what you do here is you divide each term by the x with the highest power. In this case now, the x with the highest power is x squared. As you can see, x squared has the highest power. This is the same as that, right? So when you do that, it will lead you to a point whereby you will have to divide by infinity. So any number divided by infinity, it gives you 0. So when you work this out, our answer, it gives us 5/4. Alright guys, this is basically the steps that you must take when you do limits. So I'm gonna post other videos, maybe 2 videos, whereby we solve problems, we evaluate the limit. Thank you very much guys for watching. Do not forget to subscribe, like and comment if it so happen that is something that is missing or you don't understand, or if there's something you want to add. I really appreciate that. Till next time, cheers.